Hello again. So let's say now that you want to find the sum of the first n terms of some arithmetic sequences. So we're going to be summing arithmetic sequences. Okay? So if you want to find the sum of the first n terms of some arithmetic sequence, if you only have a few terms, it's probably going to be pretty easy to find the solution, right? So, like you can use a calculator if you have some pretty short term. If you have the first just 5 or 6 terms, it's pretty easy to just use a calculator to find it. Where this gets really hard is when you have, like we had the previous example where we had, uh, um, you know, up to the 345th term. Let's say we want to find the sum of everything up to the 345th term. That's pretty crazy, right? That seems like it would be fairly hard to do. Um, the good news is that it's not though. We have a pretty good formula we can use. So to find this formula, let's like first demonstrate what we're seeing here. Okay, we're going to consider the example 2, 5, 8, 11, 14, and 17. Okay, so what you might notice is that the common difference here between each of these is 3. Each term is 3 higher than the previous term. Okay, and so we have um, a notation we use for dealing with sums. So typically we write a capital S and then we write a 6 below it here because there are 6 terms in this sequence, right? So we're going to write a 6 below it. So it's S, a capital S sub 6. And that's going to be equal to 2 plus 5 plus 8 plus 11 plus 14 plus 17. The S here, I would imagine it stands for sum, and that 6 represents you're going to sum the first 6 terms in the sequence. Okay, that's kind of what that notation means. So if you just see find S sub 6, that means you're going to find the first 6 terms of the sequence summed together. Okay, but so like I said previously, this is a short enough sequence that maybe the fastest way to do this would be to just sum these up with a calculator, right? If you see this on a test, I certainly wouldn't blame you if you wanted to just use a calculator and sum these up. Or this is probably small enough you wouldn't even need to use a calculator. But I'm going to use this for demonstration for how we can find our formula, or at least the logic behind how we get the formula. Okay, so what we can notice is the sum of 2 and 17 is 19, right? The sum of 5 and 14 is 19. And the sum of 8 and 11 is 19, right? What we're seeing here is that if you have an arithmetic sequence with a common difference between each term, the first and the last term in the sequence will add up uh, to um, to 19, or not to 19. They'll add up to some number, and then each term as you move inward towards the center will add up to 19. Not 19. In this case, it's 19, but in general, it might just be some fixed value. Okay, so now what we know is S sub 6 consists of 3 pairs of numbers that sum to 19. So how we can think of this is we have 3 terms that sum to 19, so we have 3 times 19, and that's going to give us 57. So if you want to double check me on that, run these numbers through a calculator. But what we're going to find is the sum of this sequence up to 6, the sixth term is going to be 57. Okay, so I'm not going to derive this formula for the sake of time, but taking this basic logic, we have the formula for S sub n for an arithmetic sequence is going to be n times a1 plus a n over 2. So n is going to be the number of terms in your sequence. Okay, and then a1 and an are going to be exactly like how we defined them previously. All right, so a1 is the first term, an is the nth term or the highest term or the last term in your sequence of numbers. Okay, so let's take a look at an example. Let's say, like this, the example we just did was very, like I said, it was very easy to put into a calculator. But let's say we have the sequence. Let's say we have the sequence 7 plus 10 plus 13 plus dot 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 plus 430. So this, when you see the dots here like this, what this is saying is that there are you just keep adding 3 to each term, but we're adding all of these terms up, right? So I don't know about you, but I don't want to spend the next probably 20-30 minutes adding up all of the numbers from 7 to 430, where we're, you know, skipping 3 each time, right? That seems like an unnecessary way to do that, right? Um, but a natural question might be, well, how many terms do we have exactly in this sequence, right? That seems important because we have to know the number in order to take advantage of our formula here, right? So to do that, we can look at our formula for arithmetic sequences. So to find n, consider a sub n is equal to a sub 1 plus n minus 1 times d. So if we can find each of the terms here, we can find how many sequences or how many numbers there are. Okay, so a sub n in this case, if we want to find how many there are up to 430, we're going to have 430 for a sub n. And that's going to be equal to a1, which we have is 7 here, plus n minus 1. We don't know n yet, so we're going to leave the n alone. And we know that the common difference we said was 3. Each term appears to be 3 larger than the previous term. So now what we can do is we can go ahead and solve for n. So we'll have 430 is equal to 7 plus, if we distribute this 3 to the n and to the negative 1, we'll get plus 3n minus 3. Okay, so if we solve for n, we can add 3 to both sides. We can subtract 7 from both sides, and we'll get that n is equal to, or I guess I should say, yeah, I guess just solving for n, we'll end up with n is equal to 430 minus 4 divided by 3, which is equal to 142. Okay, so we know that there are 142 terms in this sequence. So now we can take the fact that there are 142 terms in the sequence, and we can find the sum of the first 142 terms in the sequence. So we have S142 is going to be equal to 7 plus 10 plus 13 plus dot 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 plus 430. Okay, and now we can take this and we can plug in our information into our formula. So we have n is 142, so we'll have 142 times a1, which is 7, plus an, which is 430, all divided by 2. Okay, so this becomes 142 times 437 divided by 2. And plugging that into a calculator, we can get 31,027. So we know that the sum of the first 142 terms of this sequence is going to be 31,027. Okay, and I do want to make you guys aware of a different type of notation as well, really quickly. You might see this on your homework. Let's say that you have something we call a sigma notation. Okay, this funny looking shape is the Greek letter sigma, and it stands for sum. Okay, and specifically, you might see it written like this. If you see sigma with a little j equals 1, and then up to some arbitrary number up here, which we'll say is 134 for this example, and then you have some expression here, 2j plus 6. What you're really seeing here is you are plugging in each successive term and you're summing them all up, okay? So let's say we want to see what this looks like expanded, okay? This sequence is going to be, first we'll plug in j equals 1. So we'll have 2j, so 2 times 1 plus 6. That'll give us 8. If we plug in j equals 2, we'll have 2 times j, or 2 times 2 is 4, plus 6 is 10. J equals 3 will give us 6 plus 6, which is 12. And you go off until we plug in 134 time for j. So 2 times 134 plus 6, that's going to give us 274. So this note this sigma notation here is really just shorthand for writing out this whole sum here, okay? These are both acceptable ways to do this. And the nice part about this is that it actually tells you your n value. So here we know that there are 134 terms. So I prefer sigma notation because if it's given to you in that way, that means that you know how many terms there are. And you know the first term and you know the last term if you plug in j equals 1 and j equals 134. So we can now solve the sum. So S 134 is going to be equal to 134 times 8 plus 274, where A1 is 8 and AN, or A134, is 274. Okay, and we're going to divide that by 2, and if you plug that in, you'll get 18,894. So there is a quick introduction for how to deal with summing the first in terms of an arithmetic sequence.